So for us, we usually put 3 minutes wait time before we do any running on the sample. So just in case of you want the sample to make sure it's in the correct temperature.
Yeah.
And then, especially if you're having it in this room, and then you want it to be 298, once you put it in there, the heater will try to heat up the sample to 298. So we usually wait 3 minutes.
For every sample,
Yeah, we do.
Oh.
Yeah.
Well,
I mean, we do.
it's okay.
So what we do is basically that's what it says. So we'll do it again and again just to see what the number that's coming up, and then we'll use that as the a calibration number.
The real temperature changes inside because it will cool down all the time. You know?
Yeah. So so you have the cooler, the chiller that will make sure the temperature is always at this temperature for the sample. So it's like 293. 295. And I usually accept it if it's plus or minus 0.1 Kelvin.
Okay.
If it goes past that, then I will continue to optimize it. 'cause there's a lot of wait time. So.
How many sensors we have? Only photon and carbon?
What will happen if we do not equilibrate the temperature?
The older one, when we switch the
just
sensor,
things will
we
shift
need
due to
some
temperature.
critical checking.
So if you think it's always 298 and you might have certain shifts that occur. So if you're comparing the same sort of material over and over again, that can be an issue.
Yeah, but we did the standard compounds in the same temperature, in the same temperature difference, so that won't matter, right? Because we run the standard compounds at this temperature for example, it's 298 and it's different, a little difference from the real temperature. Then we run the samples at also in the same temperature. So maybe it will cancel the interference.
Yeah, I mean, if it's always
Yeah.
whatever it says 298.
Yeah.
Yeah, I mean, I just tuned it and everything, so we don't know if it's always 298 or is it fluctuating around 298.
Okay.
You know, so that's the only thing that I'm not sure about. So, wait.
So how did it get up to 304.9? That's
Yeah, I basically I'm setting it lower and higher, and I'm trying to see the behavior,
Oh, I see.
and then I'm going to try to calibrate so then it will now know what the real temperature would be.
Is it normal for it to fluctuate that much, though? Like, would it?
It wouldn't, but you know, if you're doing certain samples that are gonna maybe you want to change the temperature,
Yeah.
at least it gives you that range.
Do you guys do anything at higher temperatures?
Sometimes we
Yeah.
need some newcomers mice. We need a high temperature to get a shock, rather than get a broad.
Okay.
But we don't count that because we never had.
Yeah, it didn't have the
Temperature,
capability.
okay, just the case that their method or some is frozen inside.
Yeah, that would be bad.
But
It should be okay at 298, though.
The room temperature. We now we have the capability to high temperature because we have a cooling system.
Mhm.
When we heat the inside probe, that has to be cooled from outside, right?
Yeah.
One could do lower temperature also.
Yep. Your chiller definitely will be able to do that.
因为我在说老的那个操作界面是不是很普通，就是最通用的那个，这个叫什么 broker 的那个界面，但是这个界面有点麻烦，就是比如说我们做那个普通塞进去，对吧？你结束了，老的那个界面是 use the same sample and continue， 现在它这个不管用，它都是先弹出来 spin out。
No. You can with the same sample do hydrogen and carbon.
但是这个基本上没找到。
Well,
That's why I prefer to use the older one because we can use the same sample and continue. But this one we need to do the locking, shimming, something every time.
well, if you do that, if you do that, so I can. Yeah, that's true. But you can set up over there. Same sample. You just add, click the app, and then you go select. You don't out.
See here, basically it says what the sensor temperature was. So what I put in.
Yeah.
So I put in was 293.
Okay.
What I got out was 293.25.
25.
Take them down
Okay.
to the library.
And then 305.
Okay.
That's what I wanted.
Okay.
What was measured was 307.08. That was the most that kept coming.
Okay.
Yeah, I'm not gonna.
So it calculates like a slope.
Are you free?
Yeah.
And then okay.
There's two sensors inside, right? Oh, sorry.
One sensor.
One sensor. What two temperature?
So the other temperature is the methanol sample. It's
Yeah.
2p.
Yeah.
You can do a calculation to calculate how the peak shifts, and you can know what temperature.
Oh.
So the actual sample.
它在上面选择在那上面有个选择，上面有个 icon 嘛，还有一个就是那个 loading 就是我们以前最常用的这个。
So now it's using a correction
Oh. Okay.
because I set that slope in.
Yeah, but it's just for the methanol solvents, right?
No.
For all the solvents.
All the solvent.
Okay.
Yeah. Because once you're able to know
Is that
what the
steam
actual
stuff?
sample in there
Yeah.
and what the sensor is,
Yeah.
then from now on any sample,
Yeah.
you'll be able to correct the sensor to be what is in.
Okay.
Yeah. And methanol has that property that you can see it because it's so sensitive to how it shifts.
Okay.
这个在界面上输入一下。
Yeah. How many scans was this, Jeff? 16.
平时这样做的话，有时候也没不会用。
Okay, see, as I'm changing the temperature,
Yeah.
you see the lock?
Yeah.
I was gonna do.
So the lock starts shifting because methanol is
Okay.
very sensitive to when you start changing temperature. So the lock's like trying to find it now because
Yeah.
it's just methanol is just that sensitive. But some other samples don't really, like DMSO, doesn't matter. It'll stay pretty much very
Really
the same.
stable.
Yeah.
Okay.
So we usually have a standard of methanol. It's because we can use that property of methanol for us to help us make sure that the temperature is correct.
Okay.
So now what I do is then once it's 298, then I run it again and see how close it is to the 298 because now it should be 298,
Yeah.
right? So awesome. So you did a really good talk. That was
Oh,
really
thank
nice.
you. Thank you. I hope I, presented the project well enough.
Yeah.
I'm a little hazy on the technical details, unfortunately,
Oh, it
not
should be.
being a spectroscopist, so, that audience is,
But it's very practical. So that was the
Well,
conference. So it was
yeah.
nice.
I enjoyed it when I was able to attend. I wish I could have stayed through the whole thing, but, yeah, it was really good.
You left on Tuesday.
I had to leave right after my talk. I had a flight out at
Wow.
4:30, and it
Okay.
ended up, my flight got canceled because of the weather. I had to book another flight on a different airline,
Oh wow.
but I did get home, which was good because then we had the storm the next day. So you guys were still at the conference till Thursday, right?
Yeah.
Yeah.
So
It
I was
was
lucky.
good that you weren't leaving Wednesday because I think all the flights were canceled on Wednesday.
Yeah, I actually had to travel to Washington on Thursday, so I was fine because I didn't need to go back to Boston.
Yeah.
So
You didn't have to come too far north.
yeah, so I was fine.
Where was it?
North Carolina.
Oh.
Yeah, so it was really nice.
North Carolina.
Yeah.
It was warm.
Beechan's husband's down there.
Oh, right, okay, there you
It
go.
was that first afternoon, that Monday afternoon, it was nice and like 60 degrees. I was like, wow, enjoy it while we can because not getting that here.
Yeah, not anytime soon.
60 degrees in Sochi today too for the Olympics. They said it's not good for the ski events.
They're all complaining about the snow.
Yeah, it's I guess it's not great. It like, melts and then it freezes over. If you look at where Sochi is, it's not that far north.
Yeah, so.
I was surprised. Like, when I think of Russia, I think of northern climates and cold, but it's not that far north. Yeah. So Jimmy, Shiva offered to take you to lunch when you're ready. When you're ready to have a break.
Oh, yeah. I'm just going to load one more sample in, and then it's going to take a while, but sure, yeah.
I have to teach at 1 o'clock, so I'm going to be gone for a couple hours doing that in the lab. No, that's in the morning. This is just organic lab, but I wasn't there last week, so I had better be there this week. They may have questions. I don't like to abandon them. Even though Gopi is very well trained, I like to be there.
Okay, good. It's running.
Mm-hmm. Who's that? One of the new ones? Who? What's his name?
He's coming tomorrow.
Oh, coming tomorrow. Okay.
Let's see how.
Yeah.
Kind of successful in getting used to.
Yeah, so 298.
Yeah, so it's just a point one.
Yeah, I don't like that actually, but let's check it one more time.
Really?
Yeah, he went back.
Oh dear.
Stick.
Yeah.
Oh.
He was really
His friends with that Tarsnif kid, but he suspected he was getting.
Oh. Okay.
Suspected he was getting some heat.
Yeah, maybe.
Within.
Was he?
I don't know. From what I read, there was supposedly a chemist that helped them isolate the, bomb ingredients from the gun fireworks.
Oh boy.
I don't know whether
Yeah, we
that was
don't wanna know
authentic or
about
not. I
that.
doubt it, but I'm sure that the ties of a chemist to Tarsnif aren't that.
Let's hope.
There's not really.
So after that, he came to me and he said, your mother wants him back to leave.
Well, maybe his mother was worried about the, police pressure here, yeah.
Another sample.
He can get it.
We're just gonna put this one in here.
So what I did is, I just made sure that that by
我不知道哪
that
一
should
点
have
没有
mentioned
这
that
个。
we have internal process. So consider
他那个尺寸长度就是，如果放一个屏幕的话，你能把
Oh, really?
So I didn't want him to be anywhere here. Yeah, the chemistry is double-edged. You can use for good and then
Oh, yeah.
Usually if you see a color, it means it's still
Do you
changing.
watch
Green
Breaking
means it's...
Oh, green means still changing.
Yeah, so usually when I do that, I leave it for now.
Okay.
Yeah, it's an eye
they make
opener.
millions by making that softball.
我们这个有单
Nothing to do with the
You make more money with bad stuff.
Yeah.
unfortunate. That's
That's
the
blue.
sad
Now
part,
it's
right?
green.
Proposals after proposals, they
Yeah,
don't
you
give us money.
get nothing, that's right.
For banks that we don't need to write proposals.
No, you just have to work for guys that are
That has money.
just as likely to slit your throat as anything else, right?
Go back up into his driving Lamborghinis.
So there's
Yeah,
a water
none of that.
sample
Not around here. anyway.
with mostly water and 2 millimolars of sucrose.
Okay.
So it's very little sucrose and all water.
Oh, water. Okay.
我作为
One of the things at the conference that blew my mind is that they're really marketing 60 megahertz instruments now, benchtop 60 megahertz instruments.
Yeah, that's good. We can do it myself, but since it has, you guys have a
Actually
probe
do some
that does
stuff
it
with,
automatically, it's better to do it automatically.
Yeah, they only look like microwaves.
No, really?
That size, yeah. Like a printer size, let's
Yeah,
say.
they were literally, you know, about that, the size of the printer.
Eventually, these things will be decided.
Just to know that, see the pin.
Yeah.
Yeah. Well, the guy I told you that called me from Protosys also, you know, they market LC systems to go with VMware. LCMR.
It's pretty smooth. You don't have
Well.
to get to sample and express it, purify them. You can just get the peaks that you want.
That guy I told you about, Brian Kilday, he did do that LCNMR on some, or extracts years ago. But it's not easy, you know. His name is Brian Kilday? No, this was, that was Brian Ferrera. But this was, Brian Kilday worked with
Yeah, this is gonna take a while. So
Oh,
this,
Murphy. Brian
what's nice
Murphy.
about water is that
Yeah.
we can do.
He's doing well.
There's a shim
He
program
just
that
was,
basically
like,
checks
his
the
research was
overall
featured on a, like,
probe
NPR
and make sure
spot
that the
recently or
homogeneity is
something.
good,
They're-
but it takes a
yeah.
while.
Oh, okay.
So I'm just gonna
They're
go.
collecting samples from.
Yeah, I'm just gonna take a walk. It's just gonna take a long time, actually.
Drug leads, basically, TB leads, et cetera.
Yeah, so it's just running
It's a
something
good
right now.
stopping point.
Yeah, so it's gonna run something on its own for now. Just making sure the shim is okay. Yeah, so I will take some break. Yeah, I'll take a walk.